Yes. Hello, yeah, okay, perfect. So my name is Bhavesh, and I'm having around 7+ years of IT experience, and total in ML domain it's 6+ years. And I'm certified on various clouds, just to name like Google and Azure is like top certified partners. So we are already certified in multiple areas, data engineering, machine learning. So, so I can start with the similar context. And how many of you are aware about what ML is and what are the current challenges of the system? So, have you worked ML before, or maybe you know about it something, or you have used it? So, can you get me hands and just answer me quickly? So, have you ever worked with ML, or maybe you have used ML in some way? You use your Google app, or you use your YouTube, Netflix. So have you consumed ML, or maybe you know ML, know how it is working behind the scenes? Anything
Yeah,
like,
basically,
have you ever interacted with ML systems?
um, so recommended systems are also where we are seeing.
I'm not able to hear you very clearly.
So how is my voice? Is it clear?
Yeah, it's better. Yeah, better.
Yeah. So the recommendation system is what recommendation system is one of
Exactly.
where
Yes.
yeah, they will recommend the videos or based on your history of your watch. The way, yeah,
Correct.
that's a good thing I can see it. And one thing I
Okay.
can see in area they will predict like fair prices. Basically. Yeah, so there is
Mm-hmm.
like a lot like a crew management system in airline. So a
Mm-hmm.
lot of like
So ever,
that.
yeah, any question comes to your mind like how these systems are working behind the scenes and are scaling up for hundreds, thousands, millions of users? And depending upon which country, which city you are, based on the city preferences, everything changes. So you imagine the scale and how these problems are getting solved, and what are the operational ML system problems, because these. So how many of you worked on any ML problem? Just give me a hands or raise. Okay, yeah, I have worked on it. Quickly you can type it in the chat as well. Have you ever worked on any of the data science notebook, ML work? How many of you work with Python things?
Yes, I work.
So we'll cover some of the basic things like what ML systems are looking like and the challenges. Okay. So in the multiple research and studies that has happened from roughly around 2018 and 19 onwards. So they have figured out like 87 of the data science projects never make it into production. This is a research from multiple different companies and from Accenture, from Capgemini, Google, from other partners. It's like a very thorough research. And can you believe this? Like the 87%, or maybe it's close to 90% as well. Maybe call it 85%, whatever you like. Can you believe this? That this is such a big number that the data science projects are never making it into production. How many of you think like this is a true thing, or do you think this is a false statement? Someone quickly answer me so that I can go ahead and share some insights with you.
most of the data most of the data science projects are never went into production because basically first thing is the real time data where they're not able to
Hmm.
handle the real time data fast enough. So
Yeah,
the other problem is your ML model basically the performance of the model because it will change according to the data.
exactly.
So these are the two main reasons design person.
Absolutely. Yeah, you are very right on that. So these are main challenges, and the performance decreases with the time, and also when the data set changes. So while you are developing on a the train data set, which is like can be different than your test data set or real time data, which is coming in your production. And the development cycle is also so. Like in the companies, they develop, the data scientists are developing on the notebooks, while the production ML all happens out of the notebook. Nothing is written in the notebook. It's like, traditional software engineering. So that's why we need traditional software engineering practices infused into the ML systems so that they work like, the other systems are working. So that's why, companies like Uber and other big companies who are using, so Flipkart, Amazon, all these guys are using ML at the back end for everything. So this is why, we are calling it why the ML deployment is difficult. So because ML system at its core is divided into the three components. So one is the models, which is catered by ML pipelines. One is the code, which is catered by CI/CD pipelines. One is data, which is catered by data pipeline. So there are all the practices infused. So on my side is like data engineering work, which is creating data pipelines. On the top there is ML models that is catered by creating ML pipelines that are automated, and on the side which is like a traditional software industry. So software industry only focuses much on this. There is a data layer which is a business layer. Again, it is, there are some data engineers or maybe like software engineers themselves write the data code, but in ML we need to have all the three in sync. Otherwise our system will not perform. If anything one goes out of a picture, so we need to like get an alert or maybe notification, something has went wrong, and the system can also like try to self heal, or maybe they can have some alerts raised to the particular concerned people. So that's how the real world system works. So need to think about all the three pictures. So how many of you knew this already? Okay, think I'll consider it as a no, then I'll go ahead. So, like, hopefully you got some insights on how we are moving towards looking at the ML systems. We can also look at further details in like what is the experimental data science. So this is again a paper from NeurIPS 2015. That is a very big conference, and Google has given this paper hidden technical debt in machine learning. So this says like this paper quotes like machine learning code is only very small percentage of the entire data science project. So what does that mean? So if we think usually when we start learning ML, we mostly focus 6 months or a year entirely learning or different algorithms, how to solve a problem, notebooks. We work only in notebooks, and especially many of the data science industry people still work in notebooks. They have never gone out of the notebook. But in reality, the ML code is only a very limited percentage. If I can call it in a number, it's hardly like 5 to 7%. So this is the reality. What about the other part? So there is configuration, data collection, verification, monitoring. You have in the down you have an infrastructure, then you have a feature extraction layer. You have like all the software tools must be having analysis, process management, machine resource management. So this is all like layers, different layers. So you can read more about this in this paper. And this is like amazing thing which companies have figured out, and hence they are having machine learning engineering practices and MLOps practices in the recent times. How many of you think like this is true and you agree to this? So I want to make a little bit more interactive session. That's why like I'm asking these questions. Otherwise, like I can quickly jump off. Okay? So this is the current scenario of the teams. They are doing all the exploratory data analysis. They're preparing the data in the notebook, training the model, giving the production model, and keeping the trained model in some bucket on the notebook in some on premises. And they are manually, giving it to the training team, and then serving team. So training team is giving to the serving team. And there is a gap between that. So this is the biggest challenge, I would say, if we quote it. That's why teams are having a hard time. Somebody wants to
Hi.
say something?
Yeah, yeah.
Yeah,
This
hi.
is yeah. Good morning. Yeah, just want to understand. We are into a cloud, Azure, AWS, and Google Cloud. I'm into that and
Mm-hmm.
DevOps, Jenkins.
Mm-hmm.
How this
Mm-hmm.
ML ops that going to support for all this on the cloud, or how is going to help the ML ops only for AI?
Yeah, yeah, absolutely. So we are focused in cloud, and most of the MLOps practices are happening in the cloud. So as I told you, the data is at scale. The ML code is mostly machine intensive. So you will have to use the cloud. So be it like AWS, Azure, GCP. So we'll definitely focus on that. Okay.
Okay. Is it
And
work like a? Is it on the work
hmm?
on the top of the DevOps?
Yeah, yeah. So DevOps practices are like fundamentally used in MLOps. So if you say like MLOps is truly inspired by DevOps, I would say. So you will have your knowledge of
Or
DevOps very handy.
it's like again it works like a how Jenkins and Azure DevOps.
It's a part of that.
I'm
So
sorry,
I
I
think you
lost.
have joined recently. Hello, can you hear me?
I just joined 10 minutes ago. Sorry about that. Just
Okay.
late.
Okay, yeah, sure. So have you like seen this slide which we spoke? Like, there are three parts to it. So in Jenkins and all other tools which you use, so it's majorly for CI/CD purpose, right? But in MLOps, you will have to figure out about the data and the ML pipeline. So for that, we'll see different tools. Okay,
Yeah, fine.
yeah,
Thank you.
So basically,
okay,
what you are trying to say is we need to focus on data also along with your deployment, right?
correct. Yes. So along with the code deployment, we'll also figure out the data deployment, data pipelines, what are the data versions. We are talking about the model version, model pipelines, how we can automate everything and keep everything in sync. That is all about the MLOps. Okay.
But if a
So
person
it's
asks you what's the difference between MLOps and DevOps, by which point you can differentiate it? Like, yeah.
Yeah, this is the major differentiation factor. In DevOps, you majorly, focus more about the code principles, following the code practices, thinking about your code is to the point it is versioned or not. But in MLOps you also care about the models, because in usually in the normal apps you don't have models, right? But into the ML applications you have models. You also depend upon what data you are consuming. So if you have trained on X data, the X plus Y is a different data. If you are talking about X plus Y, you need to think about if my data is performing on this data set or not, and you need to take in action accordingly. That's the main difference. It's same fundamentals, but we are just caring more about the ML, and the ML depends upon these things.
Oh,
You got it?
yeah.
So ML ops uses the code. Is it a scripting code, Python or anything? I'm just assuming. But any other code you are going all algorithms or what kind of code it uses? I'm totally new on ML. Just asking. I
No
don't know.
worries. Yeah, yeah,
Hmm.
no worries. So majority of the industry right now uses Python, but it's not limited. There are multiple languages, so we can have. So we'll focus on Python itself, and
Mm-hmm.
we'll keep, because that's the what majority people are using. But there are many other languages you can focus which you
It
like.
supports other languages also, like Java and .NET also, or
ML
I'm
can be done in any language. So until and unless you are writing your algorithm yourself, or if you are having a library that is giving you already the models or something, so you can consume even the latest like Gen AI things. They can be consumed using a API. So it's as simple as a curl request or a REST request. So you can figure out multiple ways of doing it. So there is no limitation on any language. Okay.
okay.
Yeah. Be it Java, .NET, C++, anything. Cool. Let's go ahead.
So, yeah, yeah, yeah.
So that's about our system and what are the teams doing today. So we'll focus one other thing. There is a white paper from Google that I'm right now reading out, and this is on giving us an overview about the ML life cycle and its core capabilities. Okay, so this will be like we'll be walking through this for some time, and then I'll pause for questions, and then I can talk more about the course content and ask you some if you have any doubts on that. Cool, that works for you.
Yeah, yeah, fine.
Oh, perfect. So we right now look at the ML system, which is a ML system and what its components are. So we'll look on the MLOps life cycle, and then we'll look at the MLOps end-to-end workflow. This will give you an idea of how the real-time systems are happening and what they are caring about, and then we can see all the different uh, which is listed here, like experimentation, data processing, which we see in the workflow, but we'll look at it in the detail if time permits. So I'll keep a time bound right now, and we can do much more things. But this is again a very good paper, which is across the industry. If you see, like, data DevOps and data ops have been widely involved, and that reduce the time of to market of the software engineering. So you have reduced the like time to market of software engineering and data engineering activities by DevOps and data ops. So with the similar thing we are doing with the ML systems. So for similar things, the domain is MLOps. So it is very clear. Now, those people who are asking me differences, this is quoted in a very English, simple English language, right?
Are you sharing something, sir? Sorry about Are you sharing anything?
Yeah, yeah. So my screen is not visible to you guys. Is it not visible
It's
to you
visible.
guys?
It's visible.
Okay. I think someone of you said that it is not visible, right?
Okay. Fine, fine. No issues. Please carry on. I'll
Yeah.
take it from there.
Yeah. So this is where we are looking at the differences, and let's quickly jump down to the major, like. So we already look at the MLOps system. Let's look at life cycle and core capabilities. Even this this is similar code which we did. Like 72% of the begin the AI pilots and 2019 have not been able to deploy a single application in the production. So this is again which I am quoting from a white paper. So there are all the like proofs here, and so let's define MLOps. So what's MLOps? MLOps is a methodology for doing ML engineering that unifies the ML system development and the operationalization. So we are unifying that both processes. So simply in the DevOps, which we do, it's development and operationalization. In MLOps, we do the ML system development and ML operations. So we ops and the ML element. That's why we are calling it MLOps. So basically, it's a formal unification, and there are some steps that you follow in a standardized process. Okay, so that's what we call MLOps. So what is the benefit of MLOps? If someone can tell me, what are the benefits? If you can see, you can tell me about which we have just spoken or from your DevOps knowledge. Okay, if somebody is not able to code, we can have it here. So these are all the different benefits that MLOps practices brings on the team. So it's shorter development cycle, better collaboration, increased reliability, performance, scalability, and security of the system. So we are streamlining the operational and the governance process, and that's increased ROI. Do you know why it is the increased ROI of the investment, like the system? Anyone? This is a very common question and common sense, which we can understand. Do you know when a machine learning project, we call it a successful, and a return on investment we call it? Anyone can answer that? So it's a basic thing, right? When the ML model hits the production, when it is increasing your business, then only we'll say, okay, it is giving me some ROI. If you are doing some, POC or like,
Accuracy.
yeah. So if
Accuracy
it
is
is giving
more.
yeah, right, accuracy. But accuracy, even if you are getting it on a notebook, but not many people are able to use, or not the applications are getting supported by your ML, then what is the use of your ML model, right? So that's
Uh,
the point.
Performance-wise, it should be the production. The performance should be good.
Yes,
I can,
absolutely.
mm,
Yeah.
and it should be
But the
stable.
main fundamental, yeah, it should be stable, right?
Yeah.
Yeah, absolutely. Okay, I think that's all about the MLOps lifecycle and like workflow that in this section we'll figure out now. So this is
So,
the life cycle. Yeah.
so some of the tech stack or technology, they will launch it at the beta version or the pilot version, and then they'll come across some of the issues while developing or while deploying. But I don't think
Mm-hmm.
so. I'm do that. That is what uh, I'm thinking. It's my
Correct. Correct.
perception.
No,
Yeah.
that yeah, that is right. I mean, they work in the same fashion. So it's same like a software industry. We test it on certain users and then scale it accordingly. So that's all the very common practices. So let's look at data engineering, ML engineering, and app engineering. What is the relationship between them? Okay. So like in the left, it is a data engineering. Like once is her data ingestion, you are creating the data, you're having the source. Because for ML system, data is like oil. So without data or oil, the ML system will not run. So they need oil or maybe data. So it's all like, first in the ML system, we are gathering the data requirements. Then we are pushing the curated data into this. So in a manner that we want, if it is a labeling, we need to do the labeling. If it is unsupervised, we need to take care in some else. And in ML engineering, we use the model. Once we have the good model, we deploy it into the application. And then we also monitor in the back, like the application KPI. You able to see my arrow and have the flow? You able
Yes.
to
Yes.
understand the
Yes.
flow right now? Yeah, so
Yeah.
this
Yeah.
is data coming in. So first we have ML engineering starting the data requirements, then in the data engineering. After then we curate the data, put it into the ML engineering, then have the model output, deploy it into the app. Then again list down the KPIs, how my model is performing, if the business is satisfied, if we are getting benefit out of it or not. Then we have again this loop. So this loop is always going on, like this cycle from year to year, from year to year, and then from year to year. So again, this like it's similar like DevOps, like bringing this circle. Does this sound interesting to you, and you get the idea how this is working?
Bhavesh, I have a question.
Yes.
Sorry to
Please.
interrupt in this, because just now I joined. I think a couple of minutes session I have missed. Sorry for that.
Okay.
So, my background is belongs to DevOps and cloud. I'm working on
Okay.
AWS and Azure and the DevOps, some kind of DevOps tools.
Hmm.
So, to whom this MLOps I mean, the course will be helpful? Because I see on the screen like data engineering, ML engineering. So where the data engineer in the sense that they need to work on the Python, PySpark, and the data level. Similarly, in advanced level ML engineers, right? So is it helpful for us, like being an operational guy?
Yeah, absolutely. So that's like, you can also not worry about the data engineering or ML model building. But if you have an operational idea, right? If you have an operationalization knowledge, you can use the same for ML industry. You can get up the basics of the ML quickly, and then you can use your knowledge in the operations. You can extend your knowledge. I'm not saying like it will be directly like you are copy pasting your knowledge, but you have to enhance your knowledge.
So do we
Okay,
need to write
but you
any
can
code over?
obviously the code is there. So in the current work, do you write any code?
No, no. I have zero knowledge on the coding section.
Okay, but in the MLOps, certainly you will need coding. Okay,
Okay,
so
so
there is a
our
yeah.
code is a bit different, like a Terraform, Kubernetes, YAML files, Ansible YAML files, and all. But we usually don't use any kind of Python and any other language level of code.
Okay, understood. But yeah, in the MLOps also, like you will be using multiple tools as well as you can use Terraform, you can use all that things, but you will have to write some Python code as well. Because and in your job also it will become certainly mandatory in some time. Okay, so
So
there is
if
no
I
job
want
that
to, oh please go ahead.
no, that's the thing I'm saying that in certain time it will be the requirement of the industry. Everybody has to learn coding and they need to have some basic amount of understanding on the coding and they can implement
Agree, I
it. Okay.
completely agree. And for
Yeah.
this
So this.
MLOps, the
Mhm.
prerequisite is for me to learn Python and ML basics, right?
Yes, absolutely.
Okay.
Okay.
Thanks, Bhavesh. Thanks for your
So, Bhavesh, so Python basics is enough, or we need to learn deeply on Python?
So we can start with the basics itself, and wherever the requirement is of advanced, slowly you can increase your knowledge and in the task. But for initial level, the basics should be good, and later I think wherever the advanced thing, because at some point of time, some advanced Python is also required. Okay.
Oh,
I have a question like basically without a ML model, there is no thing called for MLOps. First of all, if we know everything about machine learning and data science, then it
Mm-hmm.
makes some sense like to know MLOps. Is that how it works? Because if someone doesn't know like how to just create a data science, so will it work? That's what obviously that's the heart of.
You Yeah, absolutely. I'll comment on that. So, as I understand and I have worked in the industry for a long time, so there needs some, knowledge about the ML system and the ML engineering perspective. I would like have the data science industry or project works, but you certainly need not go into the depth of the maths and, science of it. You just need to think about, what is for you, a model is an artifact. For you, a model is just, another thing that you use in your deployment. So you don't need to go into little like much depth, but you need to understand how it functions, how it is giving me results, what it is interacting with, how the data is getting interacted with that model, how the data is dependent, and all that things, like obviously without anything. But it's like you don't need to be a data scientist, or you don't need to have a knowledge about like entirely about how these models are built. So you need to more aware about the software engineering principles. You need to be more aware. We need to be more aware about the ML engineering perspectives, rather than focusing much on the actual model development. So that is certainly a good to have. So and it will be appreciated, right? Got it, right? Yeah.
Yeah, got it.
So let's see. This is the entire life cycle which we are talking. So we start from the top. So it's the ML model development as we are speaking. It can happen in notebook. It can happen in a Python file, in some IDE, or maybe on cloud. It can happen on any system. Once you have the ML development, you'll use that model artifacts and all the metadata to operationalize the training. So what do we mean about training operationalization? It means like you're putting the model to production and it is serving some the inputs that you are getting, okay, real time. So that's we mean by operationalization. And then we have continuous training. So once it's not a one time game. Like you have trained a model, you have done some deployment, and you forget it about it, right? It is not like that. You need to worry about it once it is in the production. Then the game starts about monitoring it, looking at it, like how it is behaving, what outputs it is giving. Is it up to the business mark? It is up to the business need. It is helping the business. So all these things come into picture. So that's why we do all that monitoring and do the continuous training. So continuous training means we need to wait for the like you can get an alert whenever the things the accuracy or the metrics drop and the business is not getting enough value as per the model requirement, and then it will give us continuous training. And after that, I think similar thing, once you have the training done, you will again deploy. So it's the same cycle. And then towards the left is, once you have the ML deployment, you serve the prediction, do the continuous monitoring, and then the same loop. So this is the entirely like loop of ML life cycle and ML problem. So it's always on. And in the middle, we have a data and model management, which is at the heart. if you don't manage your data and models, nothing is going to be of much of use. Yeah, I think there are some hands raised.
Yeah, Bhavesh. So basing on that, the chart, right? What are you saying? Can you give us a example?
Yes, absolutely. So let's say like we take Netflix, okay, or maybe YouTube. So Netflix gives you, like, how many of you watch Netflix? Like, have you used it? It's all of us,
Uh,
right?
I I use it.
Yeah. So Netflix gives you some recommendation, right? Like, this is the things that you need to watch next. Like, so you will like it, right?
Mm,
So
correct.
if you click on it, what does happen? Like, at the back end, Netflix is recommending something. It's a ML engine that is responsible for doing that. And if you like click it, so the ML engine works is successful. Like, you have clicked the where they want you to click. So basically, they have read all your data, read all your system, and they understand what will you like according to your likes and dislikes. Based on that, they are recommending. So it's nothing but ML model development deployment. So they have developed a model, they have deployed it, they are serving the prediction. So this is a prediction serving, and they are monitoring. So what happens if, like, for a month you don't click on like what you like? So the recommendation that you are getting from Netflix, you don't click. So, and what about like if all the users are doing the same thing? That means that is something wrong with the system, right?
Mm,
If they are you are not doing the task that is intended, the system will judge it. So basically, that's continuous monitoring. They are monitoring if something is going wrong, and that will trigger ML development people, or maybe the cycle. So they'll check the logs and everything. They'll check what has happened with some users, why they are not clicking, or maybe why the. So this is the simple thing. So the metric we call it is click through rate, or maybe the CTR, which is like how many people are clicking through that links that you are providing. So that this is the metric. It's a simple business metric. If the CTR goes below something threshold, it will kick uh, the people who are responsible, or maybe like they are some the product owners of that particular features. Okay.
got it. Industry level,
So
can
this
you
is
give any kind of idea, operational level?
the as in what kind of idea you want in operations.
So basically, as I said, like operation people always using the operation related stuff, right? In different clouds, like AWS and Azure or GCP, and they are using
Mhm.
some kind of different tools to build that infrastructure. So having a operational point of view, how can we use this MLOps in that point of?
Yeah, absolutely. So I will give you entire list of tools which is getting used, and like we can talk about. There is a architecture slide that I will show you. Okay.
Oh, okay, fine.
Yeah. That is that will be fine. This is just a life cycle and a theoretical point of view. So this is all the definitions that it is present. What is the processes which I have already told you. Okay. Now we'll talk about the cycle in a different manner. It will be more visual and giving you the what is the output of each step. Okay, so pay attention on this one. So ML development, as I told you, like it is configuration and the code. It is like done in a notebook setup in IDE or maybe on a cloud. Anything can be done. Okay, and then once you have this model, then you put the model or you create a training pipeline. So pipeline is nothing but a series of steps which is like happening one after another. So because you need to in ML or data science, you have a series of steps that you need to follow. So you need to chain everything into a pipeline. So for pipeline there are multiple tools which we can look at it, but for now you can understand pipeline as a simple step by step execution of code, which is one after another. And if you have a knowledge of DevOps, understand it is one container after one container. So the attachment of a container, like you have a, like having all the information given to the container, you just run one after another. Okay. For if you don't understand that, it's a code, one code after another. Okay. And it is sharing some metadata. So after this pipeline, we have a like a continuous training process. So once the pipeline is there, it will do the register the model into the model registry and do the deployment. Once you have the deployment done, you will create a prediction serving system. Like the infrastructure will be used, and you will create a package. Like it's in a general application industry. Like you can have a Flask app, you can have a Django or some other application. So in ML also you can use something similar. Okay, and then you can use the serving package. So as a container, it will be deployed on a machine or maybe on a Kubernetes instance for that like thing. So and then you will create like use some logs to monitor how the system is performing, whether something is going wrong, it is serving this prediction. You will have normal health check and everything, and you will loop back to the data. Like if something goes wrong, like I told you, right? If for 1 month a user is not clicking on the Netflix recommendation, it seems some problem. So they'll alert. Okay. So something like that, which is a very fundamental thing. So this is the entire, circle which is happening always. And the data and model management is the key of it. Like because it is used in every part. So in the initial part, you will interact with it. In the training, it will interact. Deployment, it will interact. And again in the prediction and monitoring. So it is a key part. Okay. I'll like pause for a few seconds here. Wait for questions or anything. Okay. Any questions here or maybe anybody has
Again, again, a CIC, right? Continuous integration and continuous deployment, right? This one, the pipeline is used for CI and the serving package is used for the deployment into Kubernetes. Is that correct?
Yes, yes, absolutely. You're right.
And if it is a non-containerization, if it is a containerization, we are going with a Kubernetes. Suppose want to go with a non-containerization, few of the organization will go with non-containerization. So is that also support here,
Yeah, yeah,
serving
it is
package?
supported. Yes, yes, it is supported, but ideally it is not recommended. It's a not a recommended best practice, but you can do that. Like the job can be done.
Like for data pipeline, may I know which tool we are using for data pipeline?
So there are multiple different tools available. For if you are in a GCP, it's a data flow. If you are on Azure, it's a Azure Synapse Analytics for a data warehouse. Azure ADF, there are multiple like tools, so you can use anything. That's not a
So we need
problem.
to learn that all every tool.
Not really. So we are not like going very much detail in the like data engineering perspective. You will have a high level idea, and you will need whatever it's learning. So in the ML pipeline itself, we are using a tool which is catering for our use. That will do all the whatever data pipeline work is required. So you need not learn any separate tool. Okay, for you like.
Okay,
Just mention that whatever you can use. I mean, if you have any functional knowledge, which is good, but what is required, so we'll help you.
okay, that's
Um, how much ML you need to know? Like, do you need to know like deep knowledge or basic knowledge is good?
Yeah, Bob. So as I mentioned earlier, like it's very good if you have ML knowledge. I mean, it will really help you. But if you don't, you need to get some amount of basics. So there will be needing like a certain level of knowledge that you have to acquire to use the MLOps, because there are some principles, there are some like design practices, some like methods that you need to understand. So that all things will be done.
Okay, thank you. And what tools are we covering in the training? What exactly are we covering in the training? That is
Cool. Yeah. I'll come.
okay.
We have a so I think there's some time left. We can just pause this for the moment here, this particular thing, and like as Bhavana asked, like what are we covering, what tools we are covering, we'll go in that. Okay, let's see. Like so, this is the curriculum, which is like on a high level. We can definitely add and modify this accordingly. So there is some plan to change, like add a few things here. And so we'll cover on the key components as we gave you an overview today. And there are some key components, challenges in deploying a model. You need to know about the Git versioning systems. How do you manage the ML code models and a collaborative development? So you have a testing that we will have to do for the models that we'll cover. So containerization, Docker, and orchestration of the ML environments like in a pipeline setup or in Kubernetes. So we'll use all of that in this program. So important tools as we saw, like for managing the models is model registry, and for the inference code and the pipeline we have artifact management. That is a container registry or artifact registry. So we create a version of that, we track it. So we have a model lineage, which is like giving you an idea about how your model is connected to the data in various ways. At the end, we'll have a deployment of the model, which is like multiple different strategies, as I mentioned, like REST API, serverless, using some different tools. So we are using cloud, so it will be different cloud have the different services for serverless. So scalability and performance consideration we can see about load testing, A/B testing, canary releases for the models. And once the system is live, we will have a continuous monitoring and feedback loops. And this, like how we are looking at the system and the feedback loops. That means we look in the architecture diagram and how the feedback loops are and what. So another thing is very important, which is security compliance in envelopes. Like your data is secured, privacy is handled. So there are some compliance, GDPR, HIPAA, and other things. So you'll have also model security and access control. So this is a very fundamental thing. Apart from this, we'll also focus on model fairness, biases, and to remove biases and to keep the model fair. So there are multiple things which can be added. This is on a high level. So on the infra side, it is like very important to learn a few things. As a ML engineer or doing MLOps, so you need to provision and manage the resource for the entire project. You need to handle the cost. You need to optimize it, manage GPU if you are doing deep learning. So all these things will be taken into consideration. As I mentioned, like model results are very important. So simply like interpreting the model, machine learning model, that's the explainable AI. That's like very much used in the industry widely. And explaining the model predictions, ethical considerations in the model deployment, like whether your model is following ethical practices or like it is having that all of things. So governance and documents in the ML project, like documentation and governance is a top. So you need to document everything, all the best practices you are following, what you are doing in the new versions of the models. So that is all there. I think if that gives you an idea about what the high level things will be. If there is any question, I'll wait for it.
So are we gonna do this in Jupyter Notebook, or how are we gonna learn all this? What tool?
So we are we are going to use a cloud provider that's definitely has a Jupyter notebook, and there are some different tools as well for running the pipelines. For the pipelines will be run in the Kubeflow, Kubernetes things, and then there will be different like a model registry, artifact registry, and different tools. But yeah, Jupyter notebook is a key to like work. And you can also work in your personal machines, like in a VS Code setup, IDE. We can connect our Jupyter notebook instances in our IDs.
Uh, which cloud platform we are going to use? Like
So
Azure
that
or
is again
AWS?
like, yeah, we will have to cater. So I will have to talk to the entire students and what they are preferring, and what cloud provider is preferred. And there are some benefits also when we go to certain cloud providers and who are doing top in the industry. So for example, like right now GCP and Azure are the top in the ML, like, and GCP has some new product suits which is out in the market and they are doing very well. So we'll have to compare and talk about it in a different setup. Then we can choose one provider. So we are open on that. No worries.
What
Are
is the
you going?
duration? What is the duration of
Sorry.
this course? Duration of the course.
Yeah, that will be around 35 plus hours or maybe 35 hours you can call. So I'll have to like fix on the things. Still like thing will be dependent, but it's like close to 35 hours of content. 35.
Okay. So in that 35 hours, how you will categorize it, like version controlling how many days, automation testing how many days, and what tools? This overview is okay, but what tools you are using? Definitely, I would like to know that.
Definitely, yeah. As I told you, like, Kubernetes is one of the main tools for deploying. Then for building ML pipelines, so ML flow, Kubeflow, you will learn that. And for testing, there are PyTest you can use for unit test. For Docker container, again you have Dockers, and again Kubernetes for managing that thing. So that will be learned. For model registry, there is again ML flow and Kubeflow has their own things, and there are other tools as well. So we can look into that for
So
deployment and serving. Yeah,
yeah, please.
yeah, for deployment and serving, it will be like in a REST API serverless, so you'll have to we'll help you with that, like how you package the code and things like that. So but yeah, like there are multiple different tools that are listed. You can get the details from the like communication that you get. So we'll have a detailed communication.
Yeah, that's okay. Yeah, but I want to know in depth. So how much each module will take? Like suppose if you are telling Kubernetes and Docker, suppose I'm not into this uh, DevOps or things, so I'm not aware of this Docker and Kubernetes. So to understand that, it does it how much time it takes and how do I implement that ML? So I would like to know each model how many hours you will be taking.
Sure. So right now, like I haven't got the segregation as in done, but yeah, definitely I can do and share with you guys later. So and that's a fair question as well, because every person is on a different page here, and we can keep a level of complexity and the level of understanding so that everyone understands in the course, and based on that, we'll allocate the amount and the level of resources. Okay.
So,
So
so one
we need
question,
to do that.
yeah, one question I have. Already there are some already there in the tools which are already there for Azure DevOps, and for Jenkins is there, and for GCP there are some build tools, code build and all
Hmm.
you have. But we in the ML ops, we are going to leverage those things again into the Azure, Google, GCP, and AWS. But is that are you going to cover it also with ML ops with AI also, because it's that is where it comes the picture, right? Are you going to cover how ML ops works with AI? That is what.
Yes, you're right. So we'll cover that. We'll definitely cover. Let me go to a separate. So this is one of the slides which I told you. Okay. Now your question lands me here. We have. You are able to see the screen?
Yes, yes.
Yeah.
Yeah.
So similar way, as you asked, what tools, and you guys were asking like what is the CI/CD process or cloud build or code build, whatever things. So this is the entire process. Like, so if we consider this into GCP, or maybe you have Azure, you have a different diagram. So right now I'm just using this as a reference, and you can imagine your own whatever cloud you want. So the tools will be somewhat different, but the fundamentals and the things that we are working is quite similar, and it will be not changing across it. Okay. So for imagine like if you develop a thing on your local machine or notebook, so this is a VS code, or your Jupyter notebook on local, or your anything in the cloud. So in Vertex we have Vertex notebooks. Okay. So in you have a code and config changes here, and you will put it into a GitHub. That's nothing but some repository. So we have here CSR. That's a cloud source repository. Okay. And then once you have CSR kicked in, or maybe like you have the code into that, you will build it using cloud build. So similar to cloud build, you have GitHub operations. Okay, you can use that. So you can GitLab CI/CD. Anything can be used for CI/CD. Okay. So similarly, like there is a process. You have the container registry. You can use the artifact registry, or maybe some other like AWS, Azure provider. They will have their own container registry. Okay. So in Azure they have Azure Container Registry. In GCP they have their own thing. And then for pipelines, some kubeflow pipelines can be used. MLflow pipelines can be used. So in this consideration, there are vertex pipelines, which is underlying kubeflow pipeline. So you will have once you have the containers or components registry, then you will use the pipelines, and then it will consume the data and write the model into the model registry. You're understanding how the things are interacting here, like, and then you will
Yeah.
be using the pipelines to log the experiment, towards visualize the ML data will be logged into this. Then you have a feature store as well to interact with the pipelines. Model registry, once it adds the model and you have instructions, the CI/CD will again kick in. Like once you have the models with a certain version, with a certain testing done, your model will be ready for deploying. So you will deploy in the prediction serving infrastructure. Like you will serve it for predictions, and then you will have the logs. Once you have the logs, you will read the log in some operation suite in Google. In Azure, you have your own logging mechanism. You will do the monitoring here. You will alert and trigger it again, like human in the loop, or maybe like automated triggering, like a retraining pipeline. So we'll look all of this in detail. So in the entire workflow, you will learn like from end to end. Okay.
Yeah. Thank
Yeah. So this is all about it. I just wanted to give you a brief idea. I understand, like in a 1 hour session, we are not able to do the justice, but yeah, that's what we have got. But you learn everything in the end to end. So as a MLOps person, you will have entire knowledge. You want to use the right from development up till serving the model predictions, like again getting the logs and doing all the things. Okay. So we'll look at the retraining pipeline. We'll look at different alerting mechanism, at notifying the people. Cool. I think we are on the same page. Any questions? No.
Working on. And so you're as a ML engineer, or
Sorry, what?
can you hear me?
Yeah, yeah.
Yeah, I would like to know what is a job profile. Like our job profiles are like DevOps and cloud and development or backend. So I would like to know what is your job profile.
Yeah, it's
Like
a
you're
ML engineer.
yeah.
Yeah, ML engineering.
So
Okay,
so so suppose if I want to move to ML ops, so so you said the basic we need to know machine learning. Right?
correct.
So so is will there be any requirement for MLOps to do a modification of algorithms and models what the ML engineers are doing
Not
in real
really.
time?
Not really. No. For ML
So why?
person, ML
Yeah.
ops person, they don't need.
Okay, fine. So we will be not touching any algorithms and any models. So why would we need the development part here?
Which
So you said
development
that we
part
need
you
to
mean?
have a Python development. We should have, right?
Yeah, so the entire like Kubeflow pipelines and all the machine learning codes, or it will be having inside the ML pipeline, it will be in Python, right? So you will have
Okay.
to develop in that. If you use the ML flow or Kubeflow or any other tools, right, for the pipelines, you will have to use the Python itself. So the SDKs are available in Python, correct?
Okay. Okay. And this, as you're saying that we will be working on MLflow and Kubeflow. We will be learning both MLflow and Kubeflow or any one of them.
So if you learn one tool like successfully, the another tool is very similar. You don't need to worry about it. You can see the demo for both, but while learning, I would like suggest you learn one very good, and the second will follow automatically.
Yeah. Yeah. But in our course, what would be we are learning?
That again, as I mentioned, which cloud provider you are choosing, based on that we'll have to decide. Okay.
Okay. Okay. Fine. That you would let us know, right? All that things.
Yeah, absolutely. That's what I told you. In the start of the course curriculum, we'll discuss, what are the preference. We'll look at the details of each candidate and what they are coming from. Design the course in such a way that everybody is able to pick it up, and it will be, and again, like, based on what people are having knowledge and what they are requiring. Okay.
Okay. So
So it's
my last one.
designed as
Yeah.
per students. Yeah.
Okay. My last one is, as here we are seeing there is visualization. So for visualization, are we using any visualization tools like Tableau or
So that is a some advanced stuff again, like you don't need to go very detailed into that. So you can use a basic visualization, like if you example in GCP you have a operationalization suite which is giving you a default dashboard, but in Vertex you have Vertex, yeah, tensor board. In Azure they have their own tool, so you don't need to worry about Tableau and all that thing. That's a very advanced stuff, we won't go much in detail, but you can look at very limited visibility on the visualizations, which is just required for your job, right?
no? Thank you.
Yeah. Thank
So I have one
Okay.
question. Sorry.
Hmm.
Like,
Yeah,
yeah,
Kaushik, yeah, please.
because I am a data scientist, like, so I don't know anything about this cloud and ops. So how is it helpful for me? Because I'm only pure and Java data science. So like
Correct.
how far it will, like, should I know any prerequisites for that, or like
Mm,
what
no,
is
if
the
you are
best?
if you are a data scientist, you don't need to learn any prerequisite. So that's what the course will cover for you, the cloud
Yeah.
entirely, and you will have all the tools covered, so you don't need to worry.
Okay. And I'll have one more question. Like, I have a question with this. Are you guys covering this model serialization feature? Like,
Yeah, absolutely.
yeah, okay. That,
Yeah, absolutely. That's a part of model deployment process. So we'll definitely cover. So
yeah,
whatever is required for the model to get productionized and do the job, everything will be
yeah, because most of the people are only covering the format flexible in Python, but they're not covering the ONNX for the other cross platforms models. So that's where I saw that. What I'm asking.
covered.
Yeah.
Yeah, sure. Okay, guys, thanks. I think we are off time, and then let us know if you have any questions. You can contact with the persons that you are into touch with, and they can share the questions with me, and then we can connect. Okay. Thanks a lot.